In this video, we're going to practice adding and subtracting before we start reducing. And all of our rational expressions that we add and subtract will have a common denominator. The procedure when you have a common denominator is just like for fractions. You add or subtract the numerators, you keep one copy of the common denominator, and then you try to factor and reduce. For instance, here I have three terms. They all have a common denominator of 3x. I add the numerators and simplify to get 6. Last, since 6 is 3 times 2, and I'm dividing by 3 times x, the common factor of 3 can reduce, leaving 2 over x. Here's one for you to try. See how you do. First, we're going to add the numerators and keep one common denominator. Now we're going to collect like terms. This is going to give us 5y. This will give us 0. So we'll have 5y over y. Now keep in mind, we think of this as 1 times y. So we're going to reduce the common factors of y. That's going to give us 5 over 1, or just 5. How about this one? I'm going to add the numerators and distribute. X plus 3x will give us 4x. These are opposites and will sum to 0. That'll give us 4x divided by x, and x divided by x, as long as x isn't 0, will give us a factor of 1, which when we multiply to 4 will give us 4. Here's another. I'll add the numerators and collect like terms. This time I have a trinomial. It looks like a good candidate for guess and check. This will be x and x. This will be 5 and 1. This is x squared plus 6x plus 5, so that looks good. I have a common factor here of x plus 1, and when that reduces, I'll be left with x plus 5. Most of our problems so far have dealt with addition. Now let's look at subtraction. With subtraction, you have to be very careful. A lot of students will subtract the 4, but they'll forget to subtract this subtraction of 2x. So what I would recommend is to put an extra step in there where you subtract the quantity of this other numerator. When students use this idea, then they often, when distributing, get every term right. So give it a shot and see how you do. First, I'm going to be subtracting 4 minus 2x. When I distribute, I'll subtract 4 and add 2x. Now I collect like terms. This will go to 0. This will be x squared minus 4. I notice x squared minus 4 is the difference of two squares. I factor. I notice I have a common factor of x minus 2. And after reducing, I'm left with just x plus 2. Here's another subtraction problem. After subtracting the second numerator and distributing, I can collect like terms. This will give me negative y. This will give me 0. So I'll have negative y over y squared. I have a common factor of y, which can reduce to negative 1 over y. If you want to put the negative in front, that's fine also. Try this one. I'm going to use parentheses since I need to subtract the entire trinomial. I distribute. These all become opposites. I collect like terms. This will give me negative 2x squared. This will give me 0. And then I'll be subtracting 2. Since the coefficient of the second degree term is negative, make sure you factor out a negative 2. I notice both of these sums are the same, so I have a common factor. If I think of this as 1 times x squared plus 1, they reduce to 1, and I'm left with negative 2. And here's the last one. After adding the numerators and simplifying, I have a couple of trinomials. To factor this trinomial, I'm going to use the AC method. AC is 12, B is 8. That brings to mind 6 and 2. So I'm going to rewrite the first degree term, factor out the GCF of 2x from the first two terms. That'll leave me with 2x plus 3. I'll need to think of the second 2 as 1 times 2x plus 3. I'll factor out the 2x plus 3. That'll leave me with 2x plus 1, and that'll be my numerator. In the denominator, I'm going to use guess and check. I'm going to do 2x and x, 1 and 3. That's going to give me 2x squared plus 5x plus 3. I notice I have a common factor of 2x plus 3, which can reduce, leaving me with 2x plus 1 and x plus 1. And again, it's very common for students to want to start reducing at this stage, but you can't. These are terms, they're not factors. This is fully simplified. Well, that will conclude this video where we did a little adding and subtracting before we reduced.